Can I request Ms. Sunico to lead a prayer for this afternoon?
Let us put our presence to the presence of God in the name of the Father, the Son, the Holy Spirit. Amen. Lord, as we start our class today, guide us that we understand our lessons for today, and as we start this class, Lord, help us to focus our minds and not to go anywhere and just focus on our classes and guide us. Amen.
Okay. So good afternoon, everybody. So our topic for this afternoon is about cardiovascular. But before that, do you have any questions about the respiratory that we had in the past few weeks? No question for the past few lectures. Silence means none. Okay, so Rowan. Compass. Saan ba ito mag-share sa kung slide? For a while lang ha, slide. So, okay. Slide share. Then, wait. Wait. Sige. Kuha na siya. Wait. Slideshow. Isn't there slide? Okay. Okay. So good afternoon. Can you see now my first opening slide?
Yes, Doc.
Yes, Doc.
Okay, so this topic is not very long. Maybe we can finish this in one session, but then I think we'll just follow the schedule for 2 days for each topic. Okay, so our topic is about cardiovascular system. Okay, anyone can tell me? Anyone can tell about cardiovascular, or what's your view about the word cardiovascular?
Compromises the heart and blood vessels, Doc.
Okay, what else? What else?
Remove carbon dioxide and other waste products from cells and tissues, Doc.
It will facilitate the removal of waste products from tissues. Yes. What else? Any other ideas?
Cardiovascular consists of heart, blood vessels, and blood duct.
What else? Anyone?
Cardiovascular system is sometimes called the circulatory system.
Okay. Anyone?
Transport system for oxygen and carbon dioxide.
Okay. So, cardiovascular system is a system which is composed of the heart and the vessels, and the flow system delivering blood to any parts of the body, to the organs, which is essential for its survival. At the same time, it's not just nutrients that has been delivered to different parts of the organ, but we'll also take out the unnecessary substances, the waste products in our body through that system, because it's a movement of through and through. So it moves the blood towards the heart or towards the organ, and then it is a movement also of the blood from the organ to the heart. So the heart is actually the center, of our centerpiece in our body. It facilitates everything, but it doesn't mean the cardiovascular system will exist by its own. It also needs other systems to work with in order for the body to be functioning very normal, in order to function normally. Okay. Can you hear me?
Yes, Doc.
Yes, Doc.
Yes, Doc.
So I'll just move this one. Okay. So the cardiovascular system consists of the heart, no? As I've mentioned, and 1,000 of miles of blood vessels. If you're going to connect these vessels in our body, it will result to miles, no, thousands of miles, because there's so many blood vessels in our body. There are big vessels, minute vessels, and very, very small vessels. If you're going to connect that, you can reach as far as here from Butuan or more, no, thousands of miles. Now, the heart is the muscular pump that forces the blood through the system of vessels made of arteries, veins, and capillaries. So, to give you a hint, maybe you know already what artery is. So, arteries are the one that carries blood from the heart. So, this means to say that this is this blood comes passed from the lungs for oxygenation. So, these arteries bring oxygenated blood to the cells, while the veins are the vessel that somehow bring unoxygenated blood from the tissues, and it also bring waste products on it. Okay, while the capillaries, these are connections between arteries and veins, the venules and arterioles. This is where the exchange of gas material, carbon dioxide and oxygen, takes place in the capillaries. So these vessels transport the blood, which carries oxygen, nutrients, hormones, enzymes, and cellular waste to and from the trillions of cells that make up our bodies. Okay. By the way, you can take notes as I'm doing my lecture, because I don't like doing spoon feeding to students. Okay, because I want you. You're in this level already, so you know how to manage your time and how to take notes. Don't depend or rely on my slides, okay? Because I usually do the talking and then do the explanation, but I'm not fond of doing giving notes to my lectures. Okay, so these cells need oxygen and nutrients from digested food to make the chemical energy ATP that allows the cells to function properly. So because of this closed system, because of this cardiovascular system, nutrients has been delivered, including the oxygen, it boils down in the production of ATPs, ATP. So ATP is the chemical energy being produced by any reaction, So enzymes assist in chemical reaction inside the cells, and waste products from these reactions must be transported from cardiovascular system to sites like the lungs, the kidneys, for excretion from the body. So as the product of metabolism accumulated in the body, so these substances, unwanted substances, will be carried by the closed system, which is the cardiovascular system, and then transported to some of the excretory organ like the kidneys and the lungs. So the organs that serve as a site for excretion of unwanted substances are the lungs and the kidneys. Okay, that's why we urinate. That's why we exhale. So as we exhale, we exhale. We deliver carbon dioxide out of the body. Then in kidneys about ammonia and everything. So these are the two organs that somehow help our body to eliminate waste products, the lungs and the kidneys. So the force to transport the blood is provided by cardiac muscle that makes up the bulk of the heart. So as the heart pumps, there will be corresponding movement of blood towards the distal part of the body. So in the next succeeding slides, we will know the process of the pumping mechanism of the heart, how it works, and how many chambers do we have in the heart? We have 4 chambers. We will discuss it later. Okay. The function of transportation of blood by the cardiovascular system occurs 24 hours a day. So it's 24 hours a day, 7 days a week. So it's non-stop, So your heart will work for 70 to 80 to 90 years or more, in the average lifespan for Filipinos nowadays is 70 to 80, but then in Europe they have an average lifespan of 80 to 90. So if you don't abuse our heart, if you protect our heart, then probably our heart can still function for about 90 years or more. Okay, So this is possible because the heart beats about, how many beats can the heart beat in a minute? Do you have any idea? How many beats can a heart beat in a minute?
72
60 to
times.
100. 60
Okay.
to 100 beats per
So-
minute, Doc.
So 72 the least, no? So it's 72 times a minute, no? It is a unique organ in that it can contract, rest, and immediately contract again during our entire lifetime. So the system has a series of valves that prevent blood. So in this lecture, you will also know that there are some valves in the heart chamber that preventing it from backflowing. No, because the blood should move in one direction. It should not. If the blood backflowed, then there's a problem in your heart. No, we'll talk about some problems later about in the heart, in the chambers of the heart. So it is our pumping heart that helps keep us alive and healthy. Okay, so what I say right now is that if our heart can function normally, if we don't abuse our heart or something like do some drugs to make it move, beat faster or something like that. If it's beyond its capacity in doing such job, then it will deteriorate. So our target, which is 90 years of functioning, to have a functioning heart, will be lessened. Okay. So, what's happening? Alright. Okay. So this is the diagram, showing you the heart, and its structure and functions. So if we have for the heart, so this is the structure and function. Anyway, we'll discuss this one by one later. Okay. So for the structure, we'll include the conducting system, the chambers, and the walls. So we'll be discussing this later. And then for the conducting system, how does the for a while. Oh yes, ma'am. Kadito mo na ako lecture lang kadito kayo. Buta lang kadito. Kapabal pabuto kadito. So for the conducting system here in this one, we'll be talking about how the heart generates its own electrical impulse, because there's a cyclic regeneration of that impulse in order for the heart to pump or to contract simultaneously with each other. So there's the SA node, the AV node. So these are the circuits, the circuitry of the heart, and we'll discuss it later. The AV node, the SA node, and then for the chambers we have the ventricles, and then we have the atrium. So all of this, from the atrium to the ventricles, the blood flow will not go back. It's one-way flow of blood. Up to the ejection to the ventricles to the systemic part. We'll be also discussing the walls, the endocardium, the myocardium, and epicardium. So what are the components of this, and how this particular layer works in our heart. And then we'll also discuss the function later. Okay. So first and foremost, before we will go to the physiology, we'll talk about the anatomy of the heart. So as we all know, the heart is positioned obliquely between the lungs and in the mediastinum. Maybe you're very aware of the heart because sometimes you fall in love, then you'll say, oh, it pertains to heart, your feelings and everything. But actually, it is a pumping machine in our body. It is obliquely positioned between the lungs and the mediastinum. So about 2/3 of the bulk lies to the left side of the midline of the body. So if this is the guy, so more or less your heart is in between this in the mediastinum here, and it's between the lungs. You have the right lung, the left lung, and then it will assume as a shape like a blunt cone. It's a blunt cone, okay, with the base over here and the apex over there, okay, and then usually if you make a fist, then that size of your fist will correspond to the size of your heart. No, if you make a fist now, then most likely that's the same size that you have for your heart. But for the purpose of the lecture, it is approximately 5 inches long, or 12 cm. Then it is a 3.5 inches wide. No, this is 3.5 inches here, and then for the height is 5 inches long, and then the thickness is around 2.5. So please don't forget that figures. Okay, 5 by 3.5 by 2.5. Length is the 5 inches, 3.5 is the width, and the 2.5 is the thickness of our heart. Okay, and it lies in the mediastinum, in between the two lungs. This is the rib cage over here, and then the lungs in the center. It's more on the offset on the left side. It's not more on the center, but on offset on the left side, behind the sternum. You have the sternum here, the bone. Okay. So to proceed, to give you another view of your heart. So this is the heart located in the mediastinum. This is your lungs. No, it is in between your lungs, the left and the right lung. So as you can see here, these are the great vessel. This is the aorta. This is the ejection tube from your heart. We'll talk about this later. Okay. So there are arteries and veins. Don't forget that artery carries oxygenated blood, while the veins carries deoxygenated blood. Okay, so that's why arteries are colored red and the veins are colored blue, because it's deoxygenated. Okay. So the layers. So before that, I will just jump into the layers of the heart right away. Okay. So the outermost layer of the heart is called epicardium. No? And the next layer is the myocardium. This one. If you're going to incise part of the wall, the outermost layer is the epicardium, and then the next layer, which is composed of muscle, is the myocardium. That is called myo. Myo is muscle. Then the endocardium. There's a thin layer in the wall. This is in contact with the blood, inside the chamber of the heart. So the outermost layer of the wall of the heart is called epicardium, or visceral pericardium. So the other term for epicardium is visceral pericardium. Epi means outer. That's the way how you remember it. Epi is outer. So it is a thin transparent layer composed of serous tissue and mesothelium, a type of epithelial tissue. So because of this nature, that is serous in nature, it can also be called the serous pericardium of the heart. So to prevent confusion with the pericardial sac, innermost layer, we will refer to it as the epicardium. So more or less, it's same with the pericardial sac. Actually, there's a sac that encloses the heart. I will discuss to you later. We'll be discussing about it later also. But for now, the layers of the heart are the epicardium, the outermost layer, the myocardium, and the endocardium. The other term for epicardium is the visceral pericardium. Okay. So between the epicardium and the heart and the serous pericardium, the pericardial sac is a space called the pericardial cavity. Actually, anyway, I'll be showing you in the next slides. Actually, if this is the heart, have you seen can you see my pointer? Can you see my pointer?
Yes, Doc.
Yes, Doc.
This is the heart, this is the epicardium, this is the outermost layer. Actually, there's a space, This is the pericardial sac lining. It's not shown in this picture, but it will be shown in the next slide. So there's a thin membrane over here that covers the heart, And in between the epicardium and that sac, there's a space. We call it the pericardial space. So it is very integral, because sometimes with infections, with some diseases, this space, this pericardial space will be filled with fluid, and when it's filled with fluid, then there will be restrictions. Your heart cannot expand anymore, because when it contracts, it's like that, and expands, and then shrinks, then expands. So if there is water on that space, your heart there'll be restrictions of the heart for dilatation. So just like in your lung, in terms of pneumothorax and hemothorax. So the principle is just the same. Okay. So This cavity contains a watery fluid. So there's a watery fluid in that. So the precaudal fluid, which reduces friction. So just like the lungs, there's a fluid also in the pleural space, no? But here in the precaudal space, there's also a precaudal fluid lubricating, no? The reducing friction and erosion of tissues within these membranes. Okay. So if an inflammation of the innermost layer of the precardial sac develops, it is known as pericarditis. As I've said, there's pericarditis. Pericarditis is infection of the precardial sac. So if there is inflammation, then probably there will be accumulation of fluid in this space, thereby resulting to a decrease in the relaxation of your heart. Anyway, I will expound that later. So, because the outermost layer of the heart is the outermost layer of the organ of the body, this epicardium can also be referred to as a visceral. So, visceral peritoneum or epicardium. But usually, during exams, we didn't use weird terms. We use directly, straightforward. It's epicardium. Okay. So, underneath this epicardium, no, is the second layer of the wall of the heart. Makes up the bulk of the heart. Is called the myocardium. This is compared to the three. The myocardium is much bigger or having greater structure in relation to the heart wall. No, so myocardium. This is the heart. So this is the layer of the cardiac muscle tissue. Its cells or fibers are involuntary. When you say involuntary, there are some tissues in our muscles or organs in our body that are voluntary that we can control, but for the heart, especially the cardiac muscle, is involuntary, straighted and branched. This is the type of tissues found in your heart: involuntary, straighted, and branched. So the tissue of this layer is arranged in interlacing bundles, and is the layer responsible for contraction of the heart. Okay, so remember, it's your myocardium that contracts because this is the muscle. No, the muscle. This is the one that contracts. So the epicardium is the outer layer. The myocardium is the next layer, and this is responsible for the contraction of your heart. Okay. So the next one is the third or innermost layer of the wall of the heart. Is called the endocardium. You say endo, inside, no, inside. Epi, outside. Myo, muscle. Endo, inside. So you just correlate with this terms, no, in order not to forget. So it is called endocardium. It is a thin layer of endothelium. So this endocardium is composed of endothelium. It's a very thin layer that overlies a thin layer of connective tissue penetrated by tiny blood vessels and bundles of smooth muscle. No? So it acts as a lining for the myocardium. It covers the valves of the heart. So this endocardium are the same material or tissues that covers the valves of the heart and the chordae tendineae of the valves. Anyway, you will as we go further, you will know what's chordae tendineae, what are the valves. Okay, so just for now, the walls of the heart is composed of epicardium, myocardium, and endocardium. Myocardium is muscle. It is composed of straighted involuntary muscle branch. Okay, well, this one is endothelium. The endocardium is made up of endothelium. Okay, you have questions for these slides? You have questions for these slides?
None, Doc.
None. Okay, good. Feel free to ask questions. Okay, so this is another view. No, this is the inside of the heart, and this is the layers of the heart. No, so this is the myocardium. Myocardium is muscle. Okay, and this is the endocardium over here, with this line with endothelium. No, this is the layer that's in contact with your blood inside the cardiac cavity. Okay. Okay, so this is so this is the layer that's in contact with the blood. So from the myocardium, you can see the epicardium. So this one, you see this this solid color over here, this is the epicardium. So this is the outermost portion of the heart. And then, as I told you before, there is called the pericardial sac, no? Pericardial sac. So, or the fibrous pericardium. So this is the one. So this is the one that encloses the entire heart, no? Encloses, but there's a space in between the epicardium and this one. So this is the space. So this is, imagine this is your heart, and it is wrapped by a plastic. So this is the sac, no? And this is the space over here. So when actually I failed to incorporate my quad. I operated here a cardiac. I opened here a cardiac patient here in St. Paul. It's a nice. It's in my phone. I will just show it later how the actual movement of the heart is a real one. It's so nice to doing like that. No? So if I operated on that one because I drained the fluid in this pericardial space. No, so it was referred. The patient was referred to me by the cardiologist for evacuation of the fluid here because it's having tamponade. No, when you say tamponade, the heart can no longer move because of the fluid restricting it inside. It should move freely because of that space, but because of the presence of the fluid, it hardly moved, and the ejection and the ejection fraction or the injection of blood will be decreased because of that, because it cannot dilate. When it dilate, then the blood will go inside the cavity. So because of that restriction, there's less of blood going to the heart. So I drained it. And anyway, it's in my phone. I can share it later. Okay. So these slides is very important thing is endocardium, the myocardium. This is the epicardium, and this is the pericardial space, or then pericardial sac or fibrous pericardium. Okay. So if you're going to slice in a coronal view, this is a coronal view. Okay. So you can see the chambers of the heart. This is the atrium. You have 3 chambers. This is right and this is left. Okay. And this is the ventricles over here. The ventricles. Atrium, right atrium, left atrium, and the ventricles. If you're going to slice the wall or get a piece of a wall of the heart, then you can see and then magnify it. This is the wall. Okay, the endocardium, which is this one, myocardium, the muscle, and then the epicardium, the outermost layer. Okay, so we'll be discussing later about the structures. What are these? This one, this one, this one, this one. You'll be very knowledgeable later. Okay, so this is the heart. Okay. So now let's start going to the heart in details. So first, the chambers of the heart. So the inside the heart, it is divided into 4 chambers. The one that receives the blood are the atrium, and the other one are the 2 upper chambers are called atrium. There's a left and right atrium. Okay. So this is the heart, in a frontal view. So frontal view. So if you're going to cut this coronal, then you can see the atrium. Can you see it, class? Can you see it?
Yes, Doc.
Okay.
Yes, Doc.
So this is the upper chamber, the atrium. You have the right and the left atrium, and then you have also the ventricles, the left and the right ventricles. Okay. So this is the chambers of the heart. Actually, when we talk about the real positioning of the heart, more or less, it's more or less obliquely placed. No, if you're going to view the patient in your front, what you can see right away in your direction, in your field of view, will be this part. The right atrium and the right ventricle. It's more or less directed in front. Then obliquely the posterior part. The posterior part. It's not really flat like that as shown in this slide. It's outright right and left atrium. But in the real position of the heart, if you're going to imagine it, what is exposed in the anterior most likely will be the right atrium and the right ventricle, and then obliquely the left atrium, the left ventricle, takilid gamay. Okay. So this is the heart. No, this is the heart. So each atrium, each atrium has external appendage called auricle. So auricle. So this is the atrium. This part is atrium. Though I haven't seen the cross section yet, but this is the atrium, and this is the auricle of the right atrium and the auricle of the left atrium. So the purpose of this is this increases the volume, the atrium, this auricle. No? So the lining of each atrium is smooth except for the anterior wall. No? So the lining of the atrium is smooth. No? Smooth, not just smooth all the way, except for some parts. So if we're going to dissect and open this one, so this is your atrium, okay? And this part is your ventricles already. No, right atrium, okay? So if this is the atrium, the lining of each atrium is smooth, no, like this, it's smooth. It's very smooth, no, except for the anterior atrial walls and the lining of the two auricles. So this is chamber of the atrium. It's smooth, as you can see, except for the anterior wall. So this is the anterior. We flip this up, we open this up, flip it up, and you can see that there are some trabecula, okay, or projections. This is the musculi pectinati, okay, lining of the auricle, except again the lining of the atrium is smooth except for the anterior atrial walls here, and the two auricles, the one that I've mentioned here. So these are not smooth. Okay. So why these parts are not smooth? Because this contains the projecting muscle, called the musculi pectinati. So this gives the auricle. This gives the auricle and the anterior arterial wall to be rough. And these two atrium, as I've been mentioned, there's a left and right atrium. The left and right atrium are separated from each other by the interatrial septum. Okay, I'll go back. Okay, so this is the atrium. This is the atrium. So there's the division between two atrium, the interatrial septum. Okay, inter means in between. Atrial septum. Okay, so interatrial septum is the one that divides the right and left atrium. In the ventricles also, this is also the septum. Interventricular septum. You say enter in between. Interventricular septum. This is the one that divides the two ventricles, the left and right ventricles. Interatrial septum is the one that divides the left and right atrium. Okay. So the lower two chambers, as I've mentioned, are the ventricles. So still, it is composed of right and left ventricles. So this is the right ventricle, and this is the left ventricle. Okay, the two ventricles are separated from each other by interventricular septum or internal interventricular septum. Okay, as I've mentioned before. So the muscle tissue of the atria and ventricles is separated by a connective tissue that also forms the bulbs. So these muscles over here in the atrium and the ventricles are separated by connective tissue, and this connective tissue also forms the valve. So this is the valve, So this is the valve. So how are you going to picture that out? So if this is, imagine that this is a close organ, not transected. Okay, so if this is the atrium, for a while. Okay. Okay. So if this is the atrium, this is the ventricle. No, imagine that this is closed. We didn't dissect this one. So there's our valves. This valve is just like that. It's like a piece of sheet of paper, the paper like that, covering the hole. No. So when when the what when the when the blood push this one, it will open up like that. It will open up like that. So it's more or less a guard over there. So when the pressure is greater than the tension of that valve, it will open like that, and then the blood will go transfer from the atrium to the ventricles. Okay, so these are the valves. Anyway, we'll be talking more on the structure of the valves later. So you have you have valve here. You have valve here in the atrium and ventricle on the right. You have valve here in the atrium and ventricle in the left. You also valve here for your aorta, no, and you have also valve for your pulmonary vein, pulmonary artery. Okay, so 4 valves. So how are you going to what? Wait. Well, okay. So that's for the internal portion of the heart. No, externally there's also called a coronary sulcus sinus. This separates the atria from the ventricle. So externally, without doing the cross section of the heart, there's the so-called coronary sinus. This coronary sinus somehow separates the atria from the ventricle. So this is the coronary sinus. This is outside, externally. This is a groove. When you say sinus, it's more like a groove. And this is where it is called coronary sinus, because this is where your coronary artery will pass through. So this artery will also supply the heart. So if you have some blockade in this area, then you need to have grafting, bypass grafting or something like that, because this artery over here, the coronary artery, will be the one to supply the muscles of your heart for contraction. So any blockade of this one will interfere in the pumping mechanism of the heart, because your muscle tissues will no longer contract, because it needs ATP, it needs oxygen, it needs nutrients. And if there's blockade, then the nutrients cannot go inside. So much so that the pumping mechanism of your heart will derange. That's why patients will have cardiac arrest, so soon. So if you have chest pain or something like that, take an ECG to the echo, and if a blockade will be done here, then a surgical correction should be done. It's a very complicated surgery. Anyway, for your stage, it is very good to know that there's a coronary sulcus over here, wherein the coronary veins will pass through. So this is the one that separates the atrium from your ventricle, the coronary sulcus. Okay. So the anterior interventricular sulcus and the posterior interventricular sulcus separate the right and left ventricle. So there's also anterior and posterior ventricular sulcus. So we have internal interventricular septum. So here outside it's sulcus. And external, anterior and posterior. When we say anterior, outside, this is the posterior area, and this is the anterior side, So this is the coronary sinus. Somewhere over here, it's not shown in the picture, but opposite to this one, anterior and posterior, there is the so-called anterior interventricular sulcus. But since this is posterior, then posterior interventricular sulcus, posterior interventricular sulcus. If it's in the anterior side, then anterior interventricular sulcus. This is where your blood vessels will pass through, supplying this area of your muscle of your heart. So this is very important, The coronary groove or the coronary sulcus and the interventricular sulcus to be anterior or posterior. Okay. You have questions for these slides? So what is important in these slides, again, is coronary sulcus, okay? Again, the coronary sulcus will separate your ventricles and your atrium. This is found externally in your heart. And the other one that divides the left and right ventricles are the external interventricular sulcus. But if the question will ask you what separates your ventricles inside from its inside, then the interventricular septum. Septum is the one inside. Outside is sulcus. Okay, so these are the important things to consider in this slide. So the interventricular sulcus has anterior and posterior. If it is viewed posteriorly, then it's posterior. If it is viewed anteriorly, then it's anterior. So it separates the ventricles, left and right, externally. So that's sulcus. But internally, that's septum. Do you get me? Do you get me?
Yes, Doc.
Okay. So what separates your ventricles internally? What separates your ventricles internally?
Interventricular septum.
Okay, very good.
Interventricular septum.
Okay, and then the one that separates externally is the sulcus. Okay. Okay, so that's good. Good. Now let's proceed with the vessels of the heart. No. So this is the picture. No, can you see it? So this is the coronal section of the heart. No. So this is the right atrium, the left atrium, the right ventricle, the left ventricle. We have the interventricular sulcus over here. Okay, interventricular, and then if we're going to take these two vessels, then there's interatrial septum over that divides the left and the right. So this is the aorta. Aorta is colored red because it carries oxygenated blood, while the other one is somewhat like blue. Okay, like that. Now, so the right atrium receives blood from all parts of the body. You have to remember that, that the blood from all parts of the body, from all parts of the body, from the cells, from the organs and everything, will pass through the right atrium first, via great vessels. What are these vessels? You have the superior vena cava and the inferior vena cava. This will drain right away here. Inferior vena cava and superior vena cava. This superior vena cava will drain all the blood. When you say drain, get all the blood from the organs going back to the heart. When you say drain, so this drains the blood from the upper parts of the body. This one, the superior. That's why it's very superior. Superior vena cava. This drains the blood from the body, the head, the neck, and the arms. So this is the vessel that is very responsible for conveying the blood from the upper part of the body. Again, the head, the neck, and the arms. So this the deoxygenated blood will come in this will pass through, will come in this vessel to the right of the heart. Okay, and then the other one, the inferior vena cava, is responsible for draining or getting all the blood from the lower part of the body, abdomen, you have the lower extremities, pelvic, and everything. This will pass here and then go back to the right atrium. So that's the first thing that happened. Okay. So again, the inferior vena cava, also known as the posterior vena cava, brings blood from the lower part of the body, like the legs and the abdomen. Okay. While the coronary sinus, there's such thing as coronary sinus. No, it's not found in here. No, the one that I've talked a while ago, the coronary vessel or coronary sinus, where the coronary vessel is there. No, the coronary sinus drains the blood from most part of the vessels that supply the wall. So the one that supplies the heart. So this drains all the blood from the upper extremities. Upper part of the body. I mean, the head, the upper extremity, the neck, and everything. This inferior vena cava drains all the blood from the lower extremity, like the abdomen, the legs, and everything. While the one that drains, when you say drains, don't be confused. When you say drain, get all the blood, going back, drain. So the one that drains the muscle of the heart or the heart itself is known as the coronary sinus, no? So the coronary sinus drains the blood from most of the vessels that supply the walls of the heart with blood. So coronary sinus, remember this? The superior vena cava, the inferior vena cava, and the coronary sinus. Okay, so these are the structures if you're going to dissect this one. So this is the aorta, no? The aorta, this one is the right atrium. The flow of the blood, I'll just give you a hint. The flow of the blood will be like this. From here, inferior and superior vena cava, it goes right to the right atrium. When it stocks in the right atrium, there is the valve over here. This is closed first, no? So as the pressure, but this is just an overview. I will be discussing the exact details how this blood flows from one chamber to the other. But this is just an overview that when this blood stocks in here in the right atrium, this will initially these valves are closed. So when the pressure is greater than the valve, then it will open. Then it will go to the right ventricle. So as this blood is in the right ventricle, it will go to the pulmonary artery. Okay. So this is the pulmonary artery. So when it goes to the pulmonary artery will branch into two, left and right. The left, because we have two lungs, right? We have two lungs. That's why it will branch to left and right. But the right side here is not seen, but more or less it's here, opposite to this one, because this will go to the lungs. So your unoxygenated blood from the right ventricle is not oxygenated yet. It will go to the pulmonary artery and then goes to the lung for oxygenation. Okay, to the left and to the right. So after oxygenation, it will go back to the left atrium. Okay, and then after the left atrium, through the pulmonary vein. As you can see, this is the pulmonary vein. This is connected to the lung. Imagine that there's a lung over here, and this one is connected to the lung over here. So your blood passed from this pulmonary artery to the lung. After the lung, the blood has been is now oxygenated. Then it will move to the pulmonary vein over here, back to the left atrium. So all blood coming from the left atrium are oxygenated, and then building pressure, opening this valve. When the pressure is greater here, then the valve will open. Then blood will go to the ventricles. Then from the ventricles, still this is oxygenated because the same blood from the left atrium, it will go to the aorta. So this is your aorta now. Okay, so the aorta is the passage of blood, oxygenated blood to the system. To your system. So this is the main vessel distributing your oxygenated blood to any parts of your body. And there are some branches here in the arc of the aorta, so we'll be discussing later. So that's typically the overview. Okay, again, superior inferior vena cava, unoxygenated blood goes to the right atrium, to the ventricles, and then after the ventricles, it goes to the pulmonary artery. No, left and right, because left and right because you have two lungs over here and the lungs over here. Then oxygenated. After being oxygenated, it will come out from the lungs through the pulmonary vein and go back to the left atrium, and then to the ventricle, and then ejected to the aorta and to the circulation. Now the catch point for this one is that this is I've told you before that artery supplies what? Artery supplies what?
Oxygenated blood.
Yeah.
Oxygenated.
Artery supplies oxygenated blood, except for this one. This is the only part in the body that supplies unoxygenated blood, because this is called pulmonary artery. But in fact, the blood that's passing through this vessel is unoxygenated, and it goes to the lung. So this is the only artery supplying deoxygenated blood to the organ, which is lungs. No, so and then this is the vein. So what's the function of the vein? Brings deoxygenated blood, right?
Yes.
Yes, Doc.
But in this case,
Yes,
okay. But in this case, the pulmonary vein, because this is the lungs over here, when the blood has been oxygenated, it will pass to the pulmonary vein towards the left atrium. So this is the only vessel in the body that works opposite to the general rule. The general rule is all arteries brings or carries oxygenated blood or serve as a passage for oxygenated blood. Veins carries or serves a passage for deoxygenated blood. But in this case, except for this one, the pulmonary and artery and pulmonary vein. Okay, do you get me? Do you get me?
Yes, Doc.
Yes,
Yes,
Doc.
Doc.
Please remember this one because this is a tricky question during the examination. Okay, tricky question during the examination. So pulmonary vein and pulmonary artery in the lungs are the exception for the general rule for the functions of arteries and vessels. Okay, are we clear on that? Are we clear on that?
Yes, Doc.
Okay.
Yes, Doc.
Okay, so I give you a hint what's happening, where the blood go, where the blood comes from. So we'll be tackling it later in a detailed manner. So imagine this one again in this diagram: the right atrium, the right ventricle. You have the superior vena cava draining all the blood from your upper part of your body. Then your inferior vena cava draining all the blood from the lower part of your body, and then when it goes to the right atrium, it builds up pressure. Then this what do you call this one? This valve over here will open because originally it is closed. So when when the pressure in the right atrium is greater than the tension in the valves, then it will open, then passing all the blood to the ventricles. And then when the ventricles, after ventricles, as it build up, as the pressure builds up, then it will open up the valve in the pulmonary artery. No, so pulmonary artery goes to the lungs for oxygenation. After oxygenation from the left and the right, it will go the oxygenated blood. Now oxygenated blood will pass to the pulmonary vein. For the left and right, there's a pulmonary vein also on the right, and pulmonary vein on the left going inside the left atrium. As it goes to the left atrium, it builds pressure again, opening these valves, and then goes to the left ventricle. As with the left ventricle, increasing its pressure, opening up the valves in the aorta, then the blood will go now to the circulation to be distributed with oxygen on it. Okay, so these are the heart structures. So there are 4 structures in this. I just give you a head overview. There are structures in this heart that has valves. So wait, so this is the valve over here, the right atrium and the right ventricular valve. Then we have a valve also here, and we have a valve here for the pulmonary artery and a valve for the pulmonary vein. This protects backflow of blood. Now, when the blood goes forward, it will not. There's no way that the blood will go back in here. If there is, if that happens, and there's a damming back of blood from where it comes from, then that's a problem. It's a structural problem already. Okay, you have stenosis, you have regurgitation like that. So it's a problem already. That's why during childhood, it is very, very necessary to treat children who have tonsillitis. Why? Because tonsillitis will create antigen-antibody reaction. No, it's a very long story, but there's an antigen-antibody reaction that is found in that particular organism, the M protein, which is found in that organism. The M protein is the same protein that is found in the valves. No, so antigen. No, this is no longer part of the discussion, but I just give you an idea what is happening on tonsillitis. Okay, when you have sore throat or tonsillitis, there's antigen-antibody reaction. When you say antigen is the foreign body. So your body will create an antibody. You have an antibody for that antigen. Antigen is another term for foreign body. So it will protect. It will this antibody will kill this antigen from the tonsillitis or it's usually strep organisms. No, if you have the microbiology, it's a strep organism. So he will take down this foreign body because this foreign body has M protein. This is coated with M protein, the one found in tonsillitis or something like that. No, M protein. So the antibody, our body will recognize that M protein and then kill that organism right away. The problem, are you still there? Are you still there, class? Are you
Yes,
listening?
Doc.
Yes,
Doc.
The problem, okay, the problem in tonsillitis is that the M protein found in the foreign body or the bacteria, M protein, M, is the same M protein that is found in the valves here. You have also M protein here. The problem with our body is it cannot recognize whether this M protein is coming from the bacteria or coming from our own body, which is a component found in your valves. So there's no way of recognizing it. So when the body cannot recognize the M protein that is in the valve, he's killing the antibody, or our immune system will kill the bacteria as well as killing the M protein or destroying the M protein found here. No, so that's this is where bad things happen during tonsillitis. No, because it's not destroying the bacteria alone, but as well as destroying our own body because of the M protein here found in the valves that is also found in the bacteria. However, our body cannot recognize anymore that this is part of the valve. This is normal. It's no longer, it cannot recognize that the M protein here is normal or not, is indigenous in our body. So therefore, when there's infection, our body will react to that organism, antigen, as well as destroying this M protein over here, thereby destroying these valves. That's why patients who have repeated tonsillitis 3 times in a year should that patient, or you must remove the tonsils right away, because if you don't, then you'll end up having a defective valve. So when this becomes defective, this becomes stiff. This should be very, very pliable. This one, when this becomes stiff, then there will be regurgitation, no, or there will be an easy flow of blood from this chamber to this one, because this will thicken. This will no longer be pliable. So when there's increase of blood pressure over in that chamber, the blood cannot pass easily to the next chamber because of the defective valve brought about by that antigen antibody reaction that I've been telling you a while ago. So if you have tonsillitis there more than 3 times in a year, then take it out, because it will not give you any good in the long term, because it will be destroying your heart function, especially the valve.
Recording in progress.
Okay, so that's the reason. That's the reason. Are you still there, class?
Yes, Doc.
Yes, Doc.
Yes, Doc.
Yes,
Do you get
Doc.
my point about the antigen antibody reaction?
Yes.
Okay,
Yes, Doc.
in tonsillitis. Okay, so these are things. These are nice to know things. No, so if you have that infection more than 3 times a year, then take it out. See an ENT, then the ENT will be the one to take care of it and then take it out for you. Okay, so much so this is we have valves over here. No, we have the valves over here for the pulmonary artery, for the aorta, and then the ventricles and atrium. So this is much higher compared to this one. So there's a code for that, no? So this one, aorta, the valve, the name of the valve that's covering the aorta is the aortic valve. For the pulmonary artery, the valve that is in the entrance of the pulmonary artery is the pulmonic valve. No? So this is one, on the left is mitral valve. And this one is the tricuspid valve. Okay, tricuspid valve. Okay, you get me? Aorta, aortic valve, pulmonic, pulmonary artery, pulmonic valve, mitral valve, and then tricuspid valve. Okay.
Okay, Doc. Yes, Doc.
Okay. So this is the one that I'm talking a while ago, the coronary sinus. This is the one that separates the atrium from the ventricles externally. No, And this coronary sinus drains the blood from most of the vessels that supply the wall of the heart with blood. So all the supplies, all the blood, the deoxygenated blood from the heart walls, no, will be passing here, will drain here to the coronary sinus, then will go to the right atrium for reoxygenation. Okay. So the coronary sinus is the one that drains all the oxygenated blood from the heart into the right atrium. Then the superior vena cava is the one that drains all the deoxygenated blood from the upper part of the body to the atrium. The inferior vena cava is the one that drains all the unoxygenated blood from the lower body to the atrium. Okay, get that? You get that?
Yes, Doc.
Okay.
Yes, Doc.
Good. Okay. So this is again showing you the picture. Okay. So this is the aorta. There are the branches here. Then this is the superior vena cava, the inferior vena cava. This is the pulmonary artery. No, the left pulmonary artery and then the right pulmonary artery. There are valves here. Okay, we have the aortic valve, the pulmonic semilunar valve. Then you have the mitral valve. You have the tricuspid valve. Okay, tricuspid valve. Okay. So semilunar valve. This is all of this. The aortic valve and the pulmonic valve are semilunar valve. Okay, remember that. The aortic valve and the aortic valve, the pulmonic valve are semilunar valves. Okay. Then you have also the mitral valve over here. This is the valve that is found in between the left ventricle and the right atrium. Right atrium and the left ventricle. This is the mitral valve. And on the right, the valve is known as the tricuspid valve. This is the valve that is found in between the right atrium and right ventricle. How are you going to memorize it without any confusion? So you just do like that's at your chest, no? And the mnemonics for that, is ang pogi mo talaga. Ang pogi. Ang here on the left. Ang is aortic. P, pogi is pulmonic. Mo, M is mitral. Talaga is tricuspid. Okay, just easy as that. But start on the left. Ang pogi mo talaga. Ang is aortic. Pogi is pulmonic. Mo is mitral, talaga is tricuspid. So that's the way how you figure it out, so that you will not be lost along its way, during examination. Okay. So the semilunar valves are the pulmonary and aortic valves. So the mitral valve is the one that is found in between the left atrium and ventricle. The tricuspid is right atrium and ventricle. Okay. Okay. Do you have questions for that slides? For these slides? Do you have questions for these slides?
Nando.
None. Okay. So if you are to cut the heart into two and view it from the top, no, or the sagittal section, then you'll find these valves. No, this is the mitral valve. This is the ang pogi mo talaga, no, from the ang pogi mo talaga. So this is the one, no. So okay, so this is the pulmonary semilunar valve. This is the aortic semilunar valve, no. It have three valves, three cusps, no, three cusps. Then the tricuspid valve, the only one that is two cusps is the mitral valve. Okay. No. 1, 2, 3, 1, 2, 3, 1, 2, 3. So the only one that has two cusps is the mitral valve. Okay. Okay, now, so this is a picture showing you the movement of the oxygenated and the deoxygenated blood, no, from and to the heart. So the right atrium receives blood from all parts of the body except the lungs. Okay. So again, the right atrium, this one. Another exception is the right atrium receives blood from all parts of the body except the lungs. Why? Because the lungs will drain directly here in the pulmonary vein, diba? To the left atrium, the oxygenated blood. So much so that the lungs, only the lungs that is not draining its deoxygenated blood to the right atrium. Okay, it receives this blood through 3 veins now. So as I've mentioned, that's superior vena cava, the inferior vena cava, okay, and the coronary sinus are the one draining all the blood from different parts of the body to the atrium, okay. So so this blood in the right atrium is then squeezed, no. So all the blood, as I've said, no, I'll be repeating this again so that you'll understand. It will be squeezed in the right atrium, no. Wait. So we squeeze into the right atrium, then squeeze into the right ventricle. No? The right ventricle pumps the blood into the next major vessel. So after here, the ventricle will pump it to the next vessel. The next vessel is a pulmonary vein. So you have the pulmonary valve here, or semilunar valve for the pulmonary vein, pulmonary artery. Okay, so the blood then push towards the left and right pulmonary vein. So imagine that there's the lung here. So the blood will go to the lung for oxygenation. Then right after that, the blood will be passing to the vein, pulmonary vein over here. We have the left pulmonary vein, and we have the right pulmonary vein over here. So much so that this blood that's going into the left atrium is now oxygenated, and then it goes to the left ventricle. Okay. And when it goes to the left ventricle, this will be ready for the ejection for the aorta. So you can see the valve here for the valve here for the aorta, the semilunar valve also. So as this valve opens, then all the blood from the left atrium will go to the left ventricle, and then building its pressure, opening this valve, and then thereby this blood from the ventricles, oxygenated one, will go to the aorta and ready for distribution to the systemics, okay, for the systemic circulation, okay. So you know already what happens in the gas exchange in the lungs. So I will no longer discuss it in detail here. Okay, so what is important for us to know is the flow of the blood. Oh, because this is cardiovascular, and the flow of the blood and the kind of blood that's being carried by that particular structure. So and this is during diastole. You see diastole, the relaxation. Okay, so during diastole, during diastole, actually the arteries will work together. When it dilates, the arteries will dilate, and then when it contracts, it will simultaneously contract, as well as the ventricles. The ventricles will dilate simultaneously and then contract simultaneously. So imagine that this one is, when you say dilatation, no, or diastole, you see diastole, it will relax. So when it's relaxed, when it relaxes, all the blood will go inside this chamber. So that's diastole. And then during when the pressure here exceeds the tension here in the valve, this valve will open, and then this will flow to the ventricles. Actually, when the blood reaches the atrium from the superior or inferior vena cava, this valve is closed. No, momentary
Recording
closed.
stopped.
Momentary closed. So when there's build up, are you still there, class?
Yes, Doc.
Yes, po, Doc.
Okay, so when there is build up of pressure in the atrium, exceeding the tension, the tension here in the valves, these valves will then open. Just during diastole, the relaxation, feeling in, so open, and then the blood will go into the ventricles. This is in simultaneous with the other side, okay, and then when the pressure is big enough, this will shut down. So when there's an increase of pressure, this is closed. No, during the flow, this is open and this is closed. So when this there's buildup over here, this gate will open, and this gate will open. So simultaneously, this will happen from left to right. So when this open, there'll be accumulation of blood in this ventricle, and then after that, there'll be increase in pressure. So the increase in pressure of in the ventricles will reversely place the valves to the other side. No, instead of opening, it will close. No, like that. And then when the pressure is building up, then it will go like that. So close. Once it's closed, and then further build up pressure, then the valves in your pulmonary and aortic valve will open simultaneous. No, what is happening in the atrium, left and right, will be happening in both at the same time with ventricles. So there's buildup of when pressure in the ventricles starts to build up, this will close and this will close. Your mitral and tricuspid will close, and then further buildup of pressure will open the valves in your pulmonic and your aortic valve, thereby, and then your heart will contract, thereby resulting to ejection of blood from these ventricles to the major vessels, which is the pulmonary artery or the aorta. So as shown in this slide, no. So this is the feeling. So as shown in this slide, the valve, before it contracts, there is increase in pressure, closing the valve. Here in the tricuspid and mitral valve, it's closed, and then further increase in pressure, opening this valve, the pulmonic and aortic, then eject. Then your heart will squeeze, will contract, and then ejecting this blood to this vessel. Okay, so once in the heart again, diastole, relaxation again, then the blood in the lungs will fill into this part of the left atrium, and also with here feeling. So the cycle repeat itself again and again. Okay, do you get me? Class, do you get me?
Yes, Doc.
Yes, Doc.
Yes, Doc.
I will just charge my one.
Yes, Doc.
Kung pas pwede ko mag-charge ali? Please. Ini nabantay ko. Okay. Okay, are you there?
Yes, Doc. Yes, Doc.
Okay. Okay. So can you still see my slide?
Yes, Doc.
Yes, Doc.
Yes, Doc. Doc.
Oh, okay. So can anyone tell me or discuss shortly what's happening in this picture? Any volunteer? No right or wrong.
Pwede ako.
Who can volunteer?
Ako rakan, Doc.
Okay. What exactly happened during diastole and then systole?
Okay, so at what you have said, Doc, na kung unsay mahitabo in the right atrium and right ventricle is also the same with the left atrium and left ventricle. So as the blood enters in the right atrium, diha anay siya, then there's a buildup in pressure, and so when the pressure is greater than the tension of the valve, it will open. And so with the other side, so as there is a buildup of pressure in the left ventricle, in the right ventricle, and so with the left ventricle, the mitral and the tricuspid valve will close. Amo sa John Doc, may tabo sa pika.
Then?
And then how to read this one? Systole. And there is tapos there is a pikas, Doc, kay mura gibali si Jack if there is a build up sa Kibali ang isa na saban mo close, wait first. Diyan na saban mo close sa your take sa pulmonic. Marad pa daw.
Okay, so when there is buildup of blood, no, from the atrium to the ventricles, no, there is a diastole. Yung diastole is a relaxation. When you say relax siya, dilate siya, no, so there will be rushing of blood to the atrium. Then as atrium left or right, okay, same left or right. So when there is buildup of pressure, there's a pressure that allows this makes this
Recording in
gates
progress.
open. So when this open, this will pass, the blood will freely pass to the ventricles. So as the buildup of pressure in the ventricles, there's a pressure that will somehow close the valve again, and then further increase of pressure will open these gates until such time that the ventricles will contract. So when it contracts, it will expel all the blood from the ventricles to the major vessel. This is the aorta and the pulmonary artery. So as shown in the left side, in this side, no, during ejection, the gates or the valves here in the pulmonary artery opens, and then the aorta opens, but the tricuspid, the mitral valve and the tricuspid are closed, as you can see this one. Okay, so this is normal. No, it should be closed because when this it is a common sense. No, in a normal functioning heart, it's a common sense for us to understand that this should close, because if this contracts and then this opens, then when the blood is squeezed to the vessels and it is open,
Recording stopped.
there will be, oh my God, what happened? For a while. Are you still there?
Yes, Doc. Yes.
Yes,
Yes, Doc.
For a while. Mampas? Paano na guli mampas? Di ko ano? Ano ba? Intervention?
Huh?
Nasa ba? Okay. Okay, so in this picture, in a normal heart, no, this should close, but in a diseased heart, there are sometimes that this cannot close anymore completely. So there's a regurgitation of blood to the atria, left and right atrium, in a diseased heart. That's why we need to protect our valves, no, by staying out from infection, from drugs and everything. There are some drugs that can destroy this one. So this is it, no? This is a normal. We're talking of normal functioning heart. Okay, so at least you know already the basic mechanism on the flow of blood from one chamber to the other. But we'll dig it more in a few minutes. So for now it's 3 o'clock. Then I'll give you 15 minutes to rest and then eat and then chill and then wash your face and then relax. Then we'll be back at 3:15. Okay.
Okay, Doc.
Okay, Doc. Thank you.
Thank
you,
you,
Doc.
Doc.
Thank you, Doc.
Thank you, Doc.
Thank you, Doc.
Thank you po.